Welcome to video 1.6 of Advanced Maths, which is going to be practice questions on differentiation 1. Now, first of all, I think you should give yourself a pat on the back for arriving up to this point. Differentiation, it is quite tricky to get your head around, and it's really important to understand it well to go further into further topics. And so well done for arriving all the way here, and hopefully you'll be able to answer the questions that we encounter in the practice questions right here. So let's just get straight into it. Remember to attempt the questions. It's really important that you don't just wait for me to give out the solution. Actually attempt the question. I'm not yet sure how many we'll do, probably between 5 and 10 roughly. So let's start with, in fact, probably right, f of x is equal to e to the 3x cotangent of 4x. Well, then what is f prime of x equal to? Now, I will give you it because it's in the data booklet. Cotangent of x, the derivative of cotangent of x, so d over dx cot x is equal to negative cosecant squared of x. Now, of course, you could have derived that yourself, but just for the sake of saving your brain and time, just here it is. Alright, so I'll assume you've tried. If not, please do. And so, first of all, let's look at the bigger picture. What do we have? So we have an e to the x, or e to the something, which we know how to do. We learned how to do that. Cotangent of x, which we've seen here, so that's like the main functions. And we can see, if we look at the bigger picture, that it's using the product rule, right? The last step will be to use the product rule, because we can see it's one function, which we're going to label right now, u times 1 over 1v. By the way, the reason I'm using white paper is because I'm finished my pure 300-page jotter. I finished it just with the last video, so I have to use this now. So, e to the 3x is u, so u equals e to the 3x, and v is equal to cotangent of 4x. So now what's u prime going to be? Well, u prime, it's just 3 e to the 3x. Remember, with e to the power of something, I'm not going to go through the full chain rule, because it's just, basically the derivative of this part goes here, and then you keep this part as it is. And then v prime, so chain rule tells us that the v prime part, you should be used to doing it in your head. The chain rule for simple things like this, you know that the part we multiply by the n is going to be 4, because the inside prime is just 4, and then we're multiplying that by the derivative, so it's going to be negative 4 cosecant squared of x. In fact, just for this one, I am still going to go through the process, just to show you it is minus 4 cosecant squared of x. So if we have cotangent of 4x, then we could say that, let's call this one q, is cotangent of x, and r is 4x, so q equals cot x, r equals 4x, so q prime equals minus cosecant squared of x, as I've given you here, and r prime equals 4, and so let's call this g of x, or in fact v. So v prime is equal to u prime of v times v prime is equal to, and every single time, this is just r's, q prime of r times r prime, because I'm using different symbols here, so which is negative cosecant squared of r, which is 4x, times r prime, which is 4, which is equal to negative 4 cosecant squared of 4x, which is what we have here. In fact, that's my mistake, it's meant to be 4x here, so good to check, I suppose. And so now we can apply the product rule to get that f prime of x is equal to u prime v plus uv prime, which is equal to 3 e to the 3x times v, which is cotangent of 4x, and then plus, that's u prime v plus uv prime, no, in fact, plus uv prime, e to the 3x times minus 4 cosecant squared of 4x, which is equal to e to the 3x, 3 cotangent 4x, and then the plus and the minus to minus 4 cosecant squared of 4x. So that's our final answer here. Alright, now let's look at the second question. So this covered the product rule and quite a few of more tricky functions to find the derivative of. Now next we're going to look at higher order derivatives. So if y is equal to e to the 2x times sine of x, then what are dy over dx and d squared y over dx squared, so the second derivative, equal to? So press pause and have a go, think about it quite a lot. Alright, so I'll assume you've tried. It's quite simple. Just we're going to first of all find the first derivative. So let's call this u, this is product rule again. This is v, so u equals e to the 2x, v equals sine of x, u prime equals 2e to the 2x, and v prime is equal to cosine of x. You should be able to figure this out by yourself. And so dy over dx is equal to u prime v plus uv prime, which in this case is equal to 2e to the 2x times sine of x plus e to the 2x cosine of x, which you can factor the e to the 2x, so you get e to the 2x to sine x plus cos x, and so that's dy over dx. So we've got this part here, that's done. And now we need to find d squared y over dx squared. So this is u, and this is v, a new u and a new v. So u equals e to the 2x and v is equal to 2 sine of x plus cosine of x. So u prime is equal to 2e to the 2x and v prime is equal to, well, it's just adding, so we can split this up and then add it again. So the derivative of 2 sine of x is 2 cos x, and the derivative of cos x is minus sine x, so plus and minus make a minus. So we've got all our data, and now we get that d squared y over dx squared is equal to u prime v plus uv prime, which is equal to 2e to the 2x, that's u prime times v, which is 2 sine of x plus cosine of x, and then plus uv prime, so plus u v prime to cos x minus, oh, this is still in frame, yeah, minus sine x here. Then we can factorize e to the 2x times 4, now the 2 is going here, so 4 sine x plus 2 cos x plus 2 cos x minus sine of x. Now I think I've accidentally done exactly the same example as in one of my previous videos, so I'm very sorry for that. Here we go. That's the answer. I hope I've not made a mistake. Please do tell me in the comments if I make mistakes. There's no reason for me not to make mistakes. I've never done these questions before, so they're as new for me as they are for you. Alright, now let's look at something to do maybe with inverse functions. So we'll look at, given that f of x, so we'll do, this is question 3. So f of x is equal to sine inverse of 3x. Then find f prime of root 5 divided by 9. Okay, so finding f prime of an exact value just means once you have your formula for f prime, you plug in the number, and as I did for cotangents, I'm going to give you the value of d over dx sine inverse of x, because it's in the data booklet. It's equal to 1 divided by square root 1 minus x squared, I believe, at least. So press pause, have a go as per usual, and then I will go for the answer. Alright, so first of all, we need to identify the bigger picture. So this is going to be a chain rule because it's a function of a function, and our outer function is sine inverse, which is going to be u, and our inner function is 3x, which is going to be v. So u equals sine inverse of x, v is equal to 3x. So u prime is equal to, as it says here, 1 divided by square root 1 minus x squared, and v prime is equal to 3. And now we just apply our chain rule to get that f prime of x is equal to u prime of v times v prime, which is equal to, so 1 over square root of 1 minus, and now it's v's is going in the function, so minus 3x squared times v prime, which is 3, which is equal to 3 over square root of 1 minus 9x squared. But we're not quite done because we want to find f prime of an exact value. So f prime of root 5 over 9, we're just swapping x for root 5 over 9. So it's equal to 3 divided by square root of 1 minus, now 9 times square root 5 over 9 squared, which is equal to 3 divided by square root of 1 minus 9 times 5 divided by 81, which is equal to 3 divided by square root of 1 minus 5 over 9, right? This becomes 5 over 9. You can check for yourself. And this 1 is just, a 1 is just the same as 9 over 9, right? 9 over 9 is 1, I'm sure you'll agree. So this is equal to 3 divided by square root of 4 over 9, because 9 over 9 minus 5 over 9 is 4 over 9, which is equal to 3 divided by square root of 4 over 9 is 2 over 3. This is equal to 9 over 2 equals 4.5. It's lots of this question is in the simplification. Now I've shown every step, but if you're comfortable in your head, you can probably skip this, well, maybe not this step, but you can skip a couple steps. You can go straight to this step and then go straight to this step probably, if you're comfortable enough. So maybe we can fit a question 4 in here, if it's a not too long one. So next we're going to look at finding the speed using distance, or acceleration using distance. So if we're given that the distance s meters traveled by a particle moving along a straight line after t seconds is given by s equals 5 square root of 2t plus 1 cubed, well then we are asked what is the acceleration after 4 seconds. So press pause, have a go, and my first hint is going to be that square root of something to the power of 3 is the same as something to the power of 3 over 2. Alright, so let's have a go. So the first step is to write this in index form, where we don't have big square roots going places. And so in the index form, the power of 3, the square root is just 1/2. So 1/2 times the power of 3 is just going to be 2t plus 1 to the power of 3 over 2. Now it might not be so obvious, but this is going to be chain rule, because the outer function, so this is a constant, the 5 is a constant, so we'll just put it back at the end. And the outer function is 3 over 2, well 5x to the 3 over 2, or t to the 3 over 2, and the inner function is 2t plus 1. So this is u, and this is v. So u equals 5x to the 3 over 2, and v equals 2t plus 1. Which means that u prime is just equal, by the power rule, to 15 over 2 x to the 1/2, aka 15 over 2 root x. In fact, no, we're going to leave it as x to the 1/2 because we need to do another derivative. And v prime is just equal to 2. So v of t, which is of course just the derivative of this, is equal to u prime of v times v prime, which is equal to 15 over 2, now x is just v in this case, so 2t plus 1 to the power of 1/2 times v prime, which is 2. So the 2 sort of cancel out, which is 15 times 2t plus 1 to the 1/2. But we're not done, because we want to know acceleration. So we need to take another derivative, a second derivative. So a second order derivative. So now we need to differentiate v. So u in this case is going to be 15t to the 1/2, and v is going to be 2t plus 1. So u equals 15t, in fact this was meant to be t as well, although it doesn't really matter. 15t to the 1/2 and v is equal to 2t plus 1. 2t plus 1. So u prime by the power rule is equal to 15 over 2t to the minus 1/2, and v prime is equal to 2. So acceleration, which is the second derivative of speed and the derivative of, second derivative of distance, the derivative of speed, is equal to, by the chain rule, u prime of v times v prime, which is equal to 15 over 2. Now instead of the t, we're replacing it by v, which is 2t plus 1, then to the power of negative 1/2, then times v prime, which is 2, so the 2's cancel out like last time, and so we get 15 divided by square root of 2t plus 1. We're not quite done, because the last thing we need to do is plug in the value a of 4, so at 4 seconds, so this is a, so a of 4 is equal to 15 over square root of 2 times 4 plus 1, which is equal to 15 over square root 9, which is equal to 15 over 3, which is equal to 5, and units wise were meters per second squared. So now there's sort of one last thing we need to cover, which is going to be optimization, which will also cover for us finding maximums and minimas. So this is quite an interesting question. Here it's quite a lengthy one, but it is really interesting and worth doing. So it's going to have a bit of geometry as well to start. So anyways, let's just get into it. This is question 5, I think. And if you can do this, you're really, really comfortable with the whole calculus topic. And yeah, if you can do this, then you can probably say that you're fine for differentiation 1. So there's going to be 2 parts to this. The first part is we have a movie screen. We're told we have a movie screen, like so, little diagram, theta, alpha, this is 4 meters and this is 2 meters. So basically, and this is x meters, sorry. So basically the movie screen is this thing here, okay, this line here, the 4 meters line, but it's not just flat on the floor, it's raised up 2 meters, okay, it's not just going from the floor, it's 2 meters up from the floor. And you are sitting x meters away, or not necessarily you're sitting, but from a position x meters away from the bottom of the screen, right, from this wall here. Then you want to show, first of all, in part A, that the viewing angle theta, so that's the angle you can see the screen with, is equal to, so theta is equal to 10 to the minus 1, sorry, inverse 10, not 10 to the minus 1, of 6 over x minus inverse tangent of 2 over x. So, how it goes, this is geometry, it's not as important, but it is still quite interesting to do. Alright, so I'll assume you've had a shot, so I will go for the answer. So, first of all, we need to think of how we find theta. Well, theta is actually just going to be equal to the full angle theta plus alpha minus alpha. That might seem like a tedious way to go around it, but recall, it's much easier to work with right-angled triangles. So what we're doing, if we're doing theta plus alpha minus alpha, is we're working first of all with the big triangle to find this angle, and then with this smaller triangle here. So, theta plus alpha, okay, it's equal to this angle here. And so, tangent of theta plus alpha is equal to opposite, which is 6 meters, because the full length is 6 meters. So opposite divided by hypotenuse, opposite divided by adjacent, right? 6 over x, which we can see here, which is already quite a good sign, which means that theta plus alpha is equal to inverse tan of 6 over x, right? But now to get theta, we need to subtract alpha, which we can already guess, so this part's here, so we can guess that alpha is going to be tan inverse of 2 over x. We still need to check. So alpha is equal to, let's see, so tan of alpha is equal to opposite over adjacent. This time opposite is just the 2 meters here, and adjacent is still x. This means that alpha is equal to tan inverse of 2 over x. And now theta is equal to theta plus alpha minus alpha, of course, so this minus this, which is equal to tan inverse of 6 over x minus tan inverse of 2 over x. So that's proven. The square just means proof, finished. So that's quite useful. It's, well, not necessarily useful, but it's quite interesting. In fact, actually, it is quite useful, because if you're watching a movie and you're on the best place, which you might have wondered before, now you can work it out mathematically. But the question's not over. That was part A. Don't worry if you didn't get it. This was more geometry, so don't worry too much. Part B, though, is going to be differentiation. And the question is, at what position is the viewing angle theta max? So what is a max viewing angle, and at what x? So at what distance x meters from the screen? And you can work this out using differentiation, which shows that this is one example of a real-life application. Optimization is very useful and is arguably what differentiation is most used for, and you can now use it to optimize your cinema place that you sit in to watch a movie. So, have fun, and I'll go over the answer in a second. Alright, so for optimization, recall, we need to first of all find when the derivative is equal to 0. And to do this, we need to find the derivative first of all. So, in fact, as a small challenge, if you didn't get the full question, what's going to go here? Because it's not dy over dx, is it? It's not y that's changing. So it's going to be theta. Theta is the one changing with respect to x, as x is increasing. So d theta over dx, well, what's it equal to? Let's look at our equation here, right? This is just subtracting, so we can isolate them, consider them as one thing on their own on each side. And so, let's see. Let's write it down here, in fact. For now, let's just write theta again. Equals tan inverse of 6 over x minus tan inverse of 2 over x, right? So first of all, let's just consider them separate. In this one, we have an outer function, right? This is going to be a chain rule. Tan inverse is u, and 6 over x, right, is v. So u equals tan inverse of x, yeah, and v equals 6 over x. U prime is equal to, from the data booklets, the derivative of tan inverse, I believe, is 1 over 1 plus x squared. Yeah, it is. 1 over 1 plus x squared. And the derivative of 6 over x needs a little bit of, well, you might think it needs a little bit of quotient rule, but you don't actually. For something simple like this, it's best to try and convert it to power. 1 over x is just x to the minus 1. So this is equal to 6x to the minus 1. And now you can use the power rule, so that v prime is equal to minus 6 over x squared. Because this is going to become minus 2 because you're subtracting 1. So minus 6 to the minus 2, which is just minus 6 over x squared, right? So this is v prime. Now, we're not actually going to do this one because we'll most likely be able to just copy from this one, right? It's going to be extremely similar, with the only differences of this 6 being a 2 and this 6 being a 2 here. So, the derivative is going to be, so this part here, it's going to be u prime of v times v prime, which is equal to 1 over 1 plus x squared, but in this case, I should have written this straight in, v, is going to be instead of x, so 1 plus 6 over x squared, times v prime, which is minus 6 over x squared. And this is equal to minus 6 divided by x squared plus 6 squared over x squared. I'm just going to leave it as 6 squared, so then we can contrast with this part here. So the derivative with respect to x of tan inverse of 2 over x is going to be identical, except the 6 at the top is going to be 2. So minus 2 divided by x squared plus 2 squared instead of 6 squared. So 4 divided by x squared. Now I'm going to replace this for 36. So that means, in conclusion, I guess, that d theta over dx is equal to minus 6 over x squared plus 36 over x squared, minus minus, so plus 2 over x squared plus 4 over x squared, which must be equal to 0 at the maximum. So if this is equal to 0, you can add this to both sides, which means 2 over x squared plus 4 over x squared is equal to 6 over x squared plus 36 over x squared, like so. And so now we can sort of, if you like calling it like that, cross multiply. So multiply this by this and this by this. I'm just going to move over here for the sake of space. We get the 2x squared plus 72 over x squared is equal to 6x squared plus 24 over x squared. So now we can multiply along everything by x squared. So 2x to the fourth plus 72 over x to the fourth. Plus 72 just because the x's sort of disappear, equals 6x to the fourth plus 24. And now we can subtract from both sides and isolate each side. This means that, so take away 24 from both sides. This is, so 52, that's 48, is equal to 4x to the fourth. So divide both sides by 4. You get that, so this divided by 4 is 12, equals x to the fourth. So I don't believe that's going to simplify nicely, although I'm going to check, because that would be a silly mistake if it does. Square root, 12 to the power of 1 divided by 4. Yeah, it doesn't simplify, so we're just going to leave it as 12 to the 1 over 4. So that's the x coordinates at which the maximum occurs, if I'm not mistaken. And so next what we're going to do is plug this in to the original equation to see what this maximum actually is. Alright? So, in fact, I think I may have made an error somewhere. Yes, have I made an error somewhere? It's minus 1 x squared. Actually, this doesn't seem correct. There's something weird about it. Aha. I see what I did wrong. Yes, okay. So I made a slight mistake somewhere, which hopefully you might have noticed. Although it's completely not your fault if you didn't. It's the fact this needed to be multiplied by negative 6 over x squared. So this x squared here is actually cancelled, because this was multiplied by negative 6 over x squared, and my mistake was to only put x squared in this one, not multiply this part by x squared. So ignore everything that comes after here. I'm very, very, very sorry. Hopefully you're still here and you didn't quit, because then you won't get to see the real answer. So I am very, very sorry. And so instead, the formula we actually get is the d theta over dx is equal to, so our equation before was this, but the x squared here actually just disappears, because we were multiplying by x squared on the denominator here. So I'm very, very sorry for the confusion. So now we have a simpler equation to work with, actually, arguably. And actually it would come in the same. Well, I'm still going to go through the process again, so I'm going to use this sheet of paper here. I'm going to do this one here. I don't know if I can get both on shot. Probably not. Here. So this means that since this needs to be equal to 0, well, 2 over x squared plus 4 is equal to 6 over x squared plus 36, which means, by cross multiplying again, the 2x squared plus 72 is equal to 6x squared plus 24. So 48 is equal to 4x squared. So 12 is equal to x squared. So x is equal to root 12, which is also equal to 2 root 3. And now what we do is, first of all, make a nature table to confirm it's definitely a maximum and not a minimum, because remember, we just know this is a turning point, but it could be a minimum turning point or a maximum turning point. So to do this, we make our little nature table, which is what it's called. So we have 2 root 3 here, which we know there's a change, so f prime of x is equal to 0. Then we have anything to the left and anything upwards. And so we need this sign to know ever. So hopefully if it's a maximum, this would be minus. This would be plus, so it's like this. And this would be minus, but we're not sure yet. So let's test 0 first of all. So let's look at our equation here. So at 0, this is equal to 6 over 36, right? That's 1 over 6, in fact, probably better without the calculator. So negative 1 over 6 plus 2 over 4, so plus 1/2. So 1/2 minus 1 over 6, which is simply 2 over 6, so 1/3. So this is positive beforehand. And then for an upwards, let's try x equals 3. So we get this is equal to negative 6 divided by, so we said we're trying 3. Well, actually that's a bad idea because 2 root 3 might not be, well in fact isn't higher than, 3 isn't higher than 2 root 3. So let's try 4 instead. So divided by, so x squared is 16, then plus 36, so that's the first part. And the second part, we're adding on 2 divided by, so x squared is going to be 16, and then we're adding on 4, so like this, and we're getting that this is negative, which means the derivative at this point is negative, which is what we hoped for. So 2 root 3 is a maximum. That is a maximum. So now, the very last thing to do for this very long question is to find theta, to find what is this maximum viewing angle. We know at what distance it happens, we know where to sit in the cinema, but we don't yet know how good our viewing angle is. And so it's going to be equal to, so the original equation, which we have here, is for theta. So that's going to be equal to tan inverse of 6 over 2 root 3 minus tan inverse of 2 over 2 root 3, which is just equal to tan inverse of 3 over root 3. The 3 over root 3 minus tan inverse of 2 over 2 root 3 is just 1 over root 3, like so. So that's what this is equal to. And then in the calculator, we get that this is equal to, so tan inverse of 3 divided by root 3 is minus, sorry, that's going to be close brackets, minus tan inverse of 1 divided by square root of 3 equals 30 degrees. Hopefully there isn't any errors there, but yeah, so that's our final answer. It's theta equals 30 degrees and it happens at 2 root 3 meters. That is a really lengthy video as well, actually a really lengthy question in a really lengthy video. Hopefully you stuck to the end. If at least you watched some of the questions, it's already quite a good start, but I'm really excited for the next topic, which might be my favorite, differentiation 2.